Welcome 8th grade. First of all, sorry that this is going to be a little bit late. I will get it out there and get it to you. But today we're talking about what is a solution. From the ones you may be used to ones maybe we didn't know about, to ones that we rely on every day but weren't aware of. Substances. So when we talk about substances, we're talking about all these things. Substance is matter that has the same fixed composition. Oh, like H2O, always one oxygen, two hydrogens. Carbon dioxide, always one carbon, two oxygens, and so forth. And it cannot be broken down by physical means. I can't use physical means or processes to break it down into smaller parts. It just can't happen. These are also known as compounds, all right? Water, H2O, hydrogen peroxide, H2O2, carbon dioxide, and all these other ones that are over here, okay? Now, two specific types of substances are elements that are made of only one substance and compounds that are put together in certain and specific ratios. All right? Now, mixtures is what we're going to really focus on today. With mixtures, they're combinations of substances that are not bonded together. There's no bonding. There was no chemical reaction. All right? Is matter that does not always have the same composition. Sometimes it might be uniformly mixed very nicely. Other times you might have big globs and chunks here and there. And it can be broken down by physical means. I can separate it out by color. I can heat the water and have it evaporate and have the sugar come back. The types of mixtures we talk about today: heterogeneous mixtures, homogeneous mixtures. Homogeneous, evenly mixed throughout. Heterogeneous, not necessarily. So, heterogeneous mixtures are where the substances are not mixed evenly. So, you might think of a salad. Not every part of the salad has the exact same ratio. Milk and cereal, throw a few raisins in there if you want. You can tell the different parts, and you might get 3 raisins in one bite or no raisins in another bite. Fruit salad, paleo, chickpeas. We can think there's another salad. We've got Neapolitan ice cream. We've got peanut butter and chocolate ratios. We've got vinaigrette dressing. We've got, colored beans, or green beans, jelly beans mixed together. All of those are heterogeneous mixtures, and they're not mixed evenly. You can see that, some parts may have more of one flavor and other parts may have more of another flavor. You can think of a lot of these. We've been doing this since 6th grade, so please know it. Then we have homogeneous mixtures. They're evenly mixed on a molecular level, but they're still not bonded together. Solutions are another name for these. But when we've said solutions before, we've always thought of our Kool-Aid. We've always thought of our soda. We've always thought of our lemonade. And those are solutions. But there's also things like our shampoos, things like brass and other metal alloys that are solutions that aren't the traditional liquid-solid solutions or liquid-gas solution like you have with that, or liquid-liquid solution like you have with your shampoo. So brass is a solid solution, and we'll get into that a little bit more. Steel's another one, and almost any alloy you can think of. Okay? Homogeneous mixtures are evenly mixed throughout. Thus you get the same color and texture all the way. But you can have different mixtures. More brass, less of the zinc, a little bit evener, more even, and then more zinc, less brass, or less of the copper, and they can create different alloys with different amounts of each substance. Like your sweet tea. It can be really sweet if there's lots of sugar, or really weak if there's not lots of sugar. All right? So how do solutions form? You need a solute and a solvent. The solute is what dissolves or disappears. The sugar would be our solute. The solvent is what does the dissolving. In this case, the water. When we have gas, or liquid or solid mixtures, we're going to have to find out which one is the solvent and the solute, because one will dissolve the other. Solute is sugar, and solvent is water. There are more than just liquid-solid solutions. Forming solids from solution can sometimes happen. Now, when there's a physical change, it's called crystallization. This happens when solutions cool or when some of the solvent evaporates. So you heat up rock candy. It's actually a really sugary mixture. You put that string in it, and as that cools down, the crystals will form on those sticks, and that's an example of crystallization. Hard water, if you've ever seen that water on there, maybe after going through a dishwasher or after it's left in there, that is when the evaporation happens and those minerals from the water are left behind on the glass. Both physical forms. Chemical change, a precipitate forms. Minerals from the liquid chemically react with the solute. So the water that was the liquid, the solvent, reacted with the soap that was the solute and being dissolved, and these minerals come out and they form the common thing called soap scum in this situation. That nice film you get on the shower walls and other things, all right? That, a chemical reaction took place, and we had this. So we can, by physical means, have crystallization happen and have items come out, or by chemical means, have a precipitate come out, and soap scum was our example. Types of solutions, all right. Oh, I have to go fix that. There's the liquid-solid solution. All right, we can think of our iced tea, we can think of our sugar water. Oceans have liquids and salts or solids mixed in too. We have our liquid gas solutions. Notice the oceans came up again, carbon dioxide, oxygen are in there. And we can think of our soft drinks, our sodas and other things like that that are carbonated. Liquid solutions, we talked about shampoo earlier, but there's also vinegar, mostly water, and another part is acetic acid. The water being more is the solvent, and the acetic acid gets dissolved, and we have vinegar created. We have gas. That's our atmosphere. We have mostly nitrogen, so that's the solvent, and all the other trace gases, oxygen, that get dissolved into it to make our mixture that is our atmosphere. We have our solid, which is our brass and our steel. It's when metals are mixed together, then they're both solids. We create alloys. So steel is an alloy, brass is an alloy, and almost any metal you're looking at is an alloy because they mix different metals together to get the properties that they want. All right. Page 221, Table 2, has got some more examples if you're interested in looking there. And what's in what? So I've got a statue. Didn't put a picture here because I needed more space for it. It's a 240 kilogram statue, and it's made out of an alloy that is 48% copper, 42% nickel, and 10% zinc. Well, how much copper's in there? How much nickel's in there? How much zinc is in there? How do we figure that out? Take the total mass, that 240, times, that should be times, the percent as a decimal. So like 0.48 would be 48% as a decimal, okay? So when we're looking, copper, I take that 240 times 0.48, and I get 115.2 kilograms of copper. Now if I wanted nickel, 240 times the 0.42, I get 100.8 kilograms. 48% is more than 42%, so good, my weights are there. And for the last one, zinc, 240 times 0.1, that equals 24 kilograms. And now I know how much of each is in here. Lemonade that tastes just right. You're mixing that glass of lemonade at home, and you put 65 grams of mixture into 0.5 liters of water. That'd be about the size of that water bottle you get at the basketball games. All right. Now, how many grams of mix would you need if you wanted to make 20 liters for your graduation party? Well, to solve this one, we know how to do this. We need to set up a proportion. So, my 65 grams over the 0.5 liters. Oh, that's a ratio. I don't know how much or how many grams for my 20 liters. So, what do we do now? We can cross multiply. When we cross multiply, we get 0.5x equals 1,300. Okay? Now to find the next step, we need to use inverse operations. So we divide each side by 0.5 so that x can be all by itself, and we can figure out how many grams are there. Divide by 0.5. When we do that, we find that x is 2,600 grams of mix that we'll need to make your graduation lemonade. All right, guys and gals, crash course on solutions. We'll see more later on. Thank you. Bye.